Good morning, class. So today we will revise again 3.1 Laplace transform, and then we will move on to 3.2 inverse Laplace transform, and then translation theorem. So we will try to finish today these three parts. But this one, Laplace transform, we already finished. So I will quickly go through this. Then we move on to inverse Laplace transform. And then last one is translation theorem. So if you have any questions, please write down your questions, or you can ask me, and you can stop me at any time if you wish. Okay, so we will see the slide. So the learning outcome, we already saw, define Laplace transform and then find Laplace transform. So this is the person who discovered Laplace transform, Pierre-Simon Laplace. And if you wonder what are the applications of this differential equation, so for you, in mechanical engineering, this is the very famous equation, mass spring system, m squared d square x dt square plus beta dx dt plus kx equals to ft. For electrical system, we have a circuit problem here, L d squared q dt squared plus r dq dt plus 1 over cq equals to et. So these are the applications in engineering. Of course, there are many more applications available. You can refer to any reference book. Now, this Laplace transform is used to produce an easily solvable algebraic equation. We will see this later. You must be very good in algebra, basically about the partial fraction and decomposition method. Now, we will see that later, because without that, it will be very difficult for you to find inverse Laplace. So Laplace transform is a special type of integral transform. So the origin of Laplace transform comes from integral transform. And then it has many interesting properties, very useful in solving linear initial value problems. IVP stands for initial value problems. For the application, you need not worry very much, because there are many applications in science, engineering, business, economics, finance, and so on, computer. So many fields. So the application part, there are many, so we cannot highlight everything here. At the moment, what is important here is you have to build a very strong foundation on the method. Theory little bit. So the f function of time is defined t greater than 0, and the kst is k is function of st. S is the distance, t is time. So the s parameter is constant. The variable is t, because you are integrating respect to dt. So the improper integral, because this is 0 to infinite, so we call it improper integral. This integral comes from improper integral. We call this integral transform. Kst ft dt, 0 to infinite, equals to 0 to b, let b approaches infinite, kst ft dt. This is called integral transform. So from integral transform, we create Laplace transform. So how do we do that? This is the way how we do that. But before that, this is the table. This is the table that shows all the transformation, the first column. Okay. So this is a huge table of transform, integral transform. But we are concerned on this one only, Laplace transform, this one. This one only. The rest we no need. So Laplace transform, this is L. The K is this function. And then ft we will define t1, 0, t2 infinite. This K inverse we will see later. So the K is function of st equals to est. So very particular case, e minus st. What is s? S is the parameter, t is the variable. So you integrate respect to dt, time, not respect to s. S is the constant. So from integral transform, we create Laplace transform. So this is our topic. Let ft be a function defined t greater than 0 and kst equals to e power minus st. So the integral becomes Laplace ft defined as 0 to infinite e minus st ft dt. This is definition for Laplace transform. Ft can be any function. This ft can be any function. So we got to substitute inside, we find. Is said to be Laplace transform of ft provided the integral exists. So we will integrate and we find the answer. So, but there is a notation before we find lowercase, uppercase. This Laplace small ft, the output is big Fs. As I said, from T domain, we move on to S domain. That is the meaning. T domain to S domain, T to S. So Laplace ft Fs. So this Fs is another domain, solution in the S parameter. But the T also variable. Because you take Laplace ft, the answer is in Fs. And later on, we will come back from S to T when you study the inverse Laplace. Laplace of gt is gs, capital Gs. Laplace of yt is ys. So lower case letter denote function being transformed. Capital letter denote its Laplace transform. Okay, so now you want to evaluate Laplace of 1. So your ft is 1. 0 to infinite, est. This ft you substitute with 1. So the integral become 0 to infinite e minus st 1 dt. So how to integrate this? You must be good at integration. So you must know all the formulas of integration. We are not going to explain in detail because you can do this integration by yourself. This one is integration. You practice whenever you are free. I quickly explain. Integration of est dt, this is exponential integration, e minus st divided by minus s. You are integrating respect to t. So your s is the constant. E minus st divided by minus s, 0 to infinite. Take out negative 1 over s, e minus st, 0 to infinite. But e minus st, you can write e 1 over est, 0 to infinite. You put t. T is the variable, 0 to infinite. S is a constant. S is the parameter, constant. So you don't do anything to S. S will be there. So 1 over infinite, 0. 1 over e power 0 is 1. 1 over 1, 1. So minus minus cancel off. So we need this answer, 1 over s. So what is 1 over s? Laplace of 1. So now you created Laplace of 1. Laplace of 1. So this become a formula, a standard formula. Next time you just memorize this, is enough. This is the formula. Laplace of 1 is 1 over s. Okay, similarly, you can find Laplace of t. So Laplace of t, actually 1 is 0, t power 0. So Laplace of t, Laplace of ft, so you substitute ft with t. this ft with t. General formula is this one. 0 to infinite e power minus st ft dt. So Laplace of t 0 to infinite e power minus st ft is t dt. So integration of this, you must know integration by parts. So you use udv. I'm not going to show that, you do it yourself. Integration by parts. You write down, yeah? Integration by parts. E minus st t dt, you bring t in front. You integrate this respect to t only. So if you integrate using the formula u dv, you will get minus t e minus st divided by s minus e minus st over s squared. 0 to infinite. Now you substitute this one 1 over est. This will be 0. This will be 0 minus, if you substitute infinite and minus t 0, you will get minus 1 over s squared. So the answer is 1 over s squared. This is the answer for Laplace of t. So from here, you create the table. But before that, you also can find Laplace of e power minus 3t. This is exponential function. Formula same. This one you cannot touch. You cannot modify. You cannot change. Laplace of ft 0 to infinite e minus st ft dt. This is a fixed formula. Now you substitute ft with e power minus 3t. So this right hand side becomes 0 to infinite e power minus st. Ft is e power minus 3t dt. Now this integration, you have to do it in a very nice way. That means you combine this, become this one. E power minus st minus 3t and combine again. Then easy to integrate respect to dt. Because s is constant, e minus s plus 3t divided by minus s plus 3, 0 to infinite. This one becomes 0 minus 1 over s plus 3. So the answer is 1 over s plus 3 is Laplace for e power minus 3t. So now you can create this table. So Laplace of 1 over s. Laplace of t power n is n factorial s n plus 1, n 1, 2, 3, 4, so on. Laplace of EAT 1 over s minus a. A can be any real number. So you must memorize this or you must refer to this. So we already showed these three, already finished. Now for sin kt, you can try at home. The formula is given already. Laplace of sin kt, k over s squared plus k squared. This is Laplace of kt. Laplace of cos kt, s over s squared plus q squared. This is different from sine. This one can be shown, but we already have this formula. So we make use of this formula. The number 6 is sin kt. This is the hyperbolic sign. You see h here. This is hyperbolic sign. We call it hyperbolic function. Laplace of sin kt, k over s squared minus k squared. And Laplace of cos cos kt, s over s squared minus k squared. They are not same. Cos not same as cos. Sin not same as sin. Because this one k over s squared plus k squared. This is minus. Here s over s squared plus k squared for cos. Cos s over s squared minus k squared. So you need this table in order to find Laplace. So the linear combination is you break this into two pieces. You can take out the constant outside. Laplace of ft plus beta, Laplace of gt. You know Laplace of ft is fs, the simplified form. Laplace of gt is gs. And this example shows how you break this one into two pieces. Laplace of 1 plus 10t, you cannot do one shot. You break into two pieces. Laplace of 1, Laplace of t. Laplace of 10 multiply Laplace of t. Laplace of 1, you go back to the table. Laplace of 1, 1 over s. Always must refer to the table. We cannot do it without the table. 10 Laplace of t. Laplace of t power 1, you go back here. T power 1, 1 factorial, s 1 plus 1, 2. So s power 2. So 10 over s power 2, you must simplify. Why we simplify? Because later on, we want to find inverse of this. So 1 over s plus 10, 1 over s squared. You put the horizontal line, the denominator s squared. So s squared divided by s, s plus s squared divided by s squared, 1 multiplied 10. So this is your answer. Similarly, evaluate Laplace of Xing phi t plus t squared. So we already done this. You can find Laplace of Xing phi t and then Laplace of t power 4. So for that, you can use the formula which we already done. So you can refer to previous notes. So actually, I already given the answer. Laplace of Xing phi t is 5 over s squared minus 25 plus Laplace of t power 4 is 24 over s power 5. You can simplify this using the fraction. And for this, Laplace of t to t, so 2t squared, and then Laplace of 3 plus 4, 7t, Laplace of 7t, and then Laplace of 6. So the answer will be 4s cubed plus 7s squared plus 6 over s. For this, this one, you have to have two pieces. So from 0 to 1, and then another one is from 1 to infinite. Okay, so in this case, you got to do separately. So you can write down first integral 0 to 1, 0 to 1, 0 to 1, e power minus st, minus st, and then multiply by minus 1, minus 1, and then integrate respect to t. This is the first part. Plus the other one is from 1 to infinite. 1 to infinite, e minus st, e minus st, multiplied by 1 dt. As this is as st 1 multiplied by dt. So if you use integration, you solve, and then you will get the answer 1 over s, 1 over s multiplied by e power minus s. That is the answer. That is the answer. Any question, class? Any questions so far? Before we move on to inverse Laplace. So this example is very good. You must refer to the table. Whenever you solve example 4, example 5, example 6, but example 6 is different. Example 6, you have to use the integration formula. You have to go back. This table is very important. If you can memorize, is better. If you cannot memorize, then you always refer. The final example, this example 6, Example 6, you have to use the original formula. Go back to Laplace of ft, this formula. So 0 to infinite, 0 to infinite. So you have 0 to 1 plus 1 to infinite. So this is what we call piecewise defined function, 2 pieces. Thank you, Dennis. You are welcome. Okay, so we need this table, class. So this table is very important. Please take note. Yeah, you snapshot or screenshot this table. Keep it your handphone. Or you write down in the piece of paper. This table is very important because now we are going to do inverse Laplace. So when we do the inverse Laplace, we need this table. So I'm going to change the slide now. Okay, so this is second part, 3.2, inverse Laplace. So inverse Laplace, you have to refer to Laplace also. The previous slide, number 18, 3.1, yeah? So refer to 3.1, Laplace transform. Refer to 3.1, Laplace transform. So, end of the day, you must find inverse Laplace transform for different type of function, especially polynomial t power n, exponent e at, trigonometric sine cos, and then hyperbolic function. So, if you look at this slide, from where you get inverse Laplace? From Laplace. Laplace of 1 is 1 over s. So inverse Laplace 1 over s is 1. So you refer to 3.1, slide number 18, the transform of some basic function. So we use the same table, same formula, but we use the symbol inverse Laplace. Laplace of Tn is n factorial Sn plus 1. But inverse Laplace of n factorial Sn plus 1 is t power n. Laplace of EAT is 1 over s minus a. Inverse Laplace of 1 over s minus a is the answer is EAT. So inverse Laplace must be function of t. And inverse Laplace of k over s square plus k square is sine kt. Similarly, inverse Laplace of s over s square plus k square is cos kt. And then inverse Laplace of k over s square minus k square is sin kt. Inverse Laplace of s over s square minus k square is cos kt. This table you must memorize. Without this table, we cannot do anything. So it is not possible we can solve any problem without this table. So this table is very, very important, class. We cannot do without this table. So take note, yeah. We need this table in order to find inverse Laplace. Without this table, you cannot find inverse Laplace. Okay, so how to find inverse Laplace? You see, example, inverse Laplace or 1 over s power 5. Okay, 1 over s power 5. Okay, now we want to find inverse of 1 over s power 5. So this 1 over s power 5, you see in the previous slide, it is equation number 1. You must use this one. Inverse Laplace 1 over s, but 1 over s, the inverse Laplace 1 over s is 1. But this is s power 1. But here s power 5. So s power 5, you cannot use number 1. You must use number 2. Why? Because this n, 1, 2, 3, 4, 5, and so on. So Sn plus 1, if I put n 4, then this one become s power 5. So the right formula is formula 2. This formula you must use. This is the right formula to solve this. So we use this formula. Formula you must identify from the table. Laplace of Tn, n factorial divided by Sn plus 1. Therefore, inverse Laplace of n factorial divided by Sn plus 1 is t power n. You see, both are interconnected. This formula created from here. Now, this n plus 1 is equals to 5. You equate n plus 1 equals to 5. Therefore, your n must be equals to 4. So you already find 4. So you substitute t power 4. Answer is t power 4, but here got 4 factorial divided by s power 5. But there is no 4 factorial here. So how do we do that? You watch the next slide. This is the way how you do it correctly. So the key point is match. How to match with the formula. So the formula says n plus 1, 5. So n is 4. So when you substitute n is 4, inverse Laplace s power 5, you must have 4 factorial here according to the formula. That's why you multiply and divide by 4 factorial. You put 4 factorial here, you must divide with 4 factorial here so that it is balanced. If you don't put 4 factorial here, your answer will be incorrect. Because this is n factorial. N factorial, because you said n is 4. So s power 4 plus 1, 5. This is no problem, same. But here you have to put 4 factorial. If you put 4 factorial, you must divide with 4 factorial. So what is 4 factorial? 24. So the answer is 1 over 24 t power 4. Any question, class, here? In this example, any question? Example 1. Any question here, class? Example 1. So the important thing is how to match with the formula. So the formula is given here. So you always use the formula. Formula is given here. Inverse Laplace n factorial Sn plus 1 Tn. This formula you cannot change. But you can modify the formula. That is where your expertise comes in. How to modify? According to this, you learn this now. Inverse Laplace, you put 4 factorial divided by s power 5. So outside 1 over 4 factorial. So 4 factorial cancel off. So still it is 1 over s power 5. But you put 5 factorial in order to match. This is called matching. Matching. Now, inverse Laplace over s squared plus 7. So, this one almost same as this one. So, this formula comes from sin kt. So, you match s squared plus 7. So, k squared is 7. So, k squared is equals to 7. So what is K? K must be equals to root 7. K must be equals to root 7. But you have to see the formula. So sin kt answer is inverse Laplace of k over s square plus k square. But this k is not 1 because k is root 7. So how you modify this k? You must put root 7 here and you do the balancing. So how do we do that? Watch carefully here. K squared is 7. This is how you match with the formula. Without formula, cannot. K squared 7, you only take positive value only. K root 7. A negative cannot. So fix up the expression by multiplying and dividing by root 7. So you must put root 7 here because of this formula. K, this is K squared. So you put root 7 here. Don't forget divide by 1 over root 7. If you forget to put root 7 here, you are in the wrong. Of course, it is incorrect. So 1 over root 7, inverse Laplace of this. Now you can use this formula. This one, sin kt. Sin root 70, not 70, root 70. 1 over root 7, sin root 70. This is the correct answer. This is the correct answer. Any question, class here? Dennis, are you okay, Dennis? Are you there, Dennis? Dennis. Yeah, Mohammed Dennis. What about others? Christian? Mohammed, Ahmad Bakhtia? Okay, sir. So far, no questions. Okay. Okay, sir. All right. Okay, thank you. You can stop me anytime, yeah? So, most important thing is the keyword is matching. Matching with the standard formula. So, we see more example. Now, the inverse Laplace is a linear transform, meaning you can break this into 2 pieces, 3 pieces, and 4 pieces. Because you cannot handle all in one time. This is not possible. Inverse Laplace of alpha fs plus beta gs, you take out alpha outside, inverse Laplace of fs plus beta inverse Laplace of gs. Alpha, beta constant, f and g are transform of function small f and small g. So, if you have very complicated problem like this, inverse Laplace of minus 2s plus 6 s squared plus 4, you got to decompose. This one, you cannot do one shot. So, rewrite the given function of s in 2 expression. Sometimes more than 2, 3, 4. So, to make your life easier, inverse Laplace minus 2s plus 6 over s squared plus 4, inverse Laplace minus 2s divided by s squared plus 4 plus 6 over s squared plus 4. So, you already have 2 pieces. This one 1, this one 1. Now, you break again. Break again into 2 pieces. Inverse Laplace of minus 2s s squared plus 4 and then inverse Laplace of 6s squared plus 4. For this, you must use this formula. From where this formula comes? This one from the table. Cos kt inverse Laplace s over s squared plus k squared. Because this s squared plus k squared and s is here. That's why it is suitable, matching. K squared is 4. And this one, there is no s. So here, s squared plus 4, we use sine. And in this case, k squared also 4. But since this is 6, then there is no s, so you cannot use cos. You must use sin. So the answer is here. Answer for this is cos. Answer for this one is sine. But we have to do modification. How to do modification? This minus 2 you have to put outside. It's very important. Because there is no minus 2 here. Minus 2 outside, inverse Laplace, s over s square plus, this k is 2. So in this case, your k is 2. Identify first. By matching, you identify k is 2 because 2 squared is 4. And this one is nicely fixed to this formula. So your k is 2. Therefore, this becomes cos 2t. From here. But minus 2, you don't disturb. Put it outside. Now, this one very strange because there is a k2. You must put 2 here. And then the 6 is outside. You must divide by 2. Of course, you can put 3 here straight away. But here they show the 3 in the last step. 3 sine 2t. So 6 over 2 is 3. 3 multiplied 2, 6. You get back this. But you have to modify this according to this formula. This one comes from here. And this formula is here. Sine kt, sine 2t. So this is your final answer. If you put other than this, your answer is incorrect. Okay, now we move on to this. This one, the symbol is missing here. Okay, for this, you have to, okay, I explain to you first. Evaluate inverse Laplace 1 over s minus 1 multiplied by s minus 2. So there is no straight formula. If you look at the table, there is no formula for this. So if you go back to the table, this is the table we have. Okay, I show you the table, this one. So there is no straight formula. This is the major problem you are going to face in the future. This one, this one. So how to do this, I will explain to you step by step. You take a piece of paper and then a pencil or pen, write down. Example 4. But you have to wait. This example, you wait for a while. Example 5, more complicated. You see, very bombastic. Inverse Laplace s square plus 6s plus 9 divided by, you see, many factors. All these small s, not big S. There is a typo error. Change it to small s. S minus 1, s minus 2 multiplied by s plus 4. How to handle this? How to handle this? You have to study algebra. Another subject, algebra. So you have to study algebra. I show you what is this algebra. Algebra, write down, algebra. In algebra, you have to study what we call partial fraction. So for that, for handle these two problems and many more problems in the future, you must know these 6 formulas. You take a snapshot on this. You can put it in your handphone so that always you see this, or write down in a piece of paper. See these 6 formulas. What is this formula? It helps you to solve inverse Laplace transform, but it is not Laplace transform. It is called partial fraction. It's another topic. But we need this. This is the backbone. Of course, you can use other methods. That is up to you. But end of the day, your answer must be the same. You cannot have 2 different answers. Inverse Laplace. So in order to help you to overcome the problem, just now you saw example 4 and example 5. This table is very, very important. What is this table for? This one, form of rational function. This is the problem. The solution is in the third column. This column, form of the partial fraction. This is what we call decomposition. you decompose it, small fractions. After that, easy to use the table. So if you see your inverse Laplace in this form, px plus q divided by x minus a, x minus b, a not equals to b. If this is the form, then the answer is a over x minus a plus b over x minus b. What is a? What is b? You have to calculate. In order to calculate that, we have to use the algebra. But here now they are telling you how to do decomposition only. But how to find a, capital A and b, that is algebra. You have to use algebra to solve the problem. We will show you an example. Now, this is number one. Number two, if the form is px plus q, but the denominator is different from number one, because this is x minus a squared. It can be x minus a power 3 power 4. So when you do the decomposition, it becomes a divided by x minus a plus d divided by x minus a squared. So this is increasing the power. What is a? What is b? We have to calculate. That is our duty, to calculate a and b. After that only you can use inverse Laplace. So number 3, you must memorize these 6 formulas, class. Number 3, px squared qx plus r. This is a numerator. The x is is power 2. Divide by the denominator x cubed, x minus a, x minus b, x minus c. Now this is a very interesting formula because a, b, c all are not same. These are the non-repeated terms. So if you want to do decompose, a over x minus a, b over x minus b, plus c over x minus c. You can see the difference. Number 1, number 2, number 3, all are difference. Okay, if the form is in this type, then the answer is this one. So you have to use this method. After that, calculate what is A, what is B, what is C. And number 4, the numerator px squared plus qx plus r divided by x minus a squared, x minus b. The power here is 2. Power here is 3. Therefore, you can do the repetition for this. A over x minus a, b over x minus a squared, but the c over x minus b. X minus b. So, number 5, px squared plus qx plus r. But the x minus a power 3 multiply x minus b, a not equals to b. Since it's power 3, you got to do 3 times. But this must be power 2, otherwise cannot. Px squared plus qx plus r, a over x minus a, b over x minus a squared, c over x minus a cube, plus d over x minus c. So we have to calculate a what, b what, c what, and d what. We have to calculate. The last one is number 6. Px squared plus qx plus r, x minus a, multiplied by x squared plus bx plus c. This x squared plus bx plus c cannot be factorized. That's why. Cannot be factorized. Therefore, the partial fraction will be a over x minus a plus, since this is x squared bx plus c, you must have bx plus c as the numerator. Now class, you must be very familiar with this table. Without this table, at the moment, you cannot solve this problem unless you have other method. So other method, we are not recommending to you at the moment. At the moment, we are just want to use this table. Again, the keyword is matching. So if you look at the example, write down inverse Laplace 1 over s minus 1, s minus 2. This one is suitable to formula number 1 class. This one. This one and then this one. So out of 6 formula or 6 types, we select number 1. This one. We select this one. So how do we do that? Write down here. First, take out 1 over s minus 1, multiply s minus 2. Write down equals to a over s minus 1 plus b over s minus 2. Now, if you do the partial fraction, 1 over s minus 1, s minus 2 equals to the denominator s minus 1 multiply s minus 2. And the numerator will be a multiply s minus 2 plus b multiplied by s minus 1. This is the partial fraction. Now, the denominator are same, left hand side, right hand side. So the numerator will be 1. So write down here, 1 will be equals to as minus 2, as minus 2, as minus 2, as minus 2, the bracket, plus b s minus 1. So as we mentioned, the a, b is the constant. You solve this equation. The constant is 0. The constant is 1. The as bs, a plus b is 0. So you create the equation a plus b. You create the equation a plus b equals to 0. This is equation number 1. You write down equation number 1. And then minus 2a, minus 2a, minus 2a, minus 2a, minus b equals to 1. This is the constant. This is 1. So this is equation number 2. Equation number 2. So if you solve a plus b equals to 0, minus 2a minus b equals to 2. If you take 1 plus 2, so minus a will be equals to 1. So the answer is your a is minus 1. This is algebra. A is minus 1. And then you substitute a minus 1 inside equation 1. You get your b equals to 1. So you already found a and b. So if you put a minus 1, b 1, so inverse Laplace of minus 1 over s minus 1, the answer is, final answer, minus e power t, because your s is 1. S is 1. And then plus b, 1 over s minus 2. So your answer is EAT. So your a is 2. So plus e power 2t. So this is answer 2t. This is your final answer, class. So your final answer, inverse Laplace 1 over s minus 1, s minus 2 is minus e power t plus e power 2t. So this is your final answer. Yeah, Roger Wong. Yes, Roger. Roger Wong, please. Sir, can you repeat again? You must use your paper and pencil. Write down 1 over s minus 1 multiply s minus 2 equals to partial fraction. Use this table. Write down A over S minus 1 plus B over S minus 2. Write down. Use number 1. So this is your guide now. Okay. After that, 1 over S minus 1, S minus 2, left hand side. Right hand side, you must have A multiplied by S minus 2 plus B multiplied by S minus 1 divided by S minus 1 multiply S minus 2. You simplify. And you equate left hand side, right hand side. That will be 1 equals to A multiplied by S minus 2 plus B multiplied by S minus 1. Now, you equate the constant and the S power. So, S power, the left hand side is 1. So, that is minus constant is S power 1 is 0, left hand side. Right hand side, A plus B. Constant, left hand side 1, right hand side minus 2A minus B equals to 1. This A plus B equals 0 is constant. So you solve these two equation class, you find A minus 1, B 1. Answer A minus 1, B 1. So that means the value here A is minus 1 and your B is 1. So you already have this. And then you find inverse Laplace. So inverse Laplace of minus 1 over S minus 1 is minus E power T. This is the answer. Plus inverse Laplace of 1 over S minus 2. Answer is E power 2T. So this is the final answer. So inverse Laplace of this 1 over S minus 1 S minus 2 is minus E power T plus E power 2T. You can try at home. You can try at home. Is it okay, Roger? Yeah. So, Roger, what you do, you use this formula. A over X minus A, B over X minus B. That means the partial fraction. I'm talking about the inside one, this one. You take out this, put it inside here. Inside here. You find your A, you find your B. So the answer I gave you just now, A is minus 1 and your B is 1. You try to work out. But this one, not very hard, but very lengthy. So you have to follow quickly. I can give you the answer. For example 4, your equation A plus B, okay, I write down here, sorry, A plus B equals to 0. Okay, this one we call it equation 1. Okay, I write down here, equation 1. And then minus 2A minus B equals to 1. So you call this as equation 2. So you create this class. I write down here, watch this. A plus B equals to 0. Minus 2A minus B equals to 1. You solve 1 and 2, you find your A is A equals to -1. And then your B equals to 1. So you already have that. Now, the inverse Laplace of that is inverse Laplace, the final answer, inverse Laplace of 1 over s minus 1, s minus 2, take down, yeah? The answer is minus e power 1t plus e power 2t. This is the answer, class. This is the answer. A equals inverse Laplace. The answer for this, the answer for this is here. This is the answer. Minus e power t plus e power 2t. So I'm using this star button for the power. Power. So if you solve the problem number 1, this one, you get the answer minus e power t plus e power 2t. Now we want to solve this one. Take a piece of paper and pencil. Take piece of paper, pencil. I can give you the final answer. I can give you the final answer. So number 2, the final answer is minus 16 over 5 multiplied by e power t. I will show you later. Plus 25 over 6 e power 2t. E power 2t plus 1 over 30 e power minus 40. So for this, s squared plus 6s plus 9, s minus 1, s minus 2, s plus 4, you have to use this formula. Which formula? Because this one, you see here got s squared. And this one, s multiply s, small s, yeah? S, typo error. S multiply s squared multiply s power cube. So if you match the table here, this formula is suitable, number 3. We have to select number 3. This is the correct formula. This one is the correct formula. Because px squared plus qx plus r divided by x minus a, x minus b, x minus c. So here you have s minus 1, s minus 2, s plus 4. Now, if you use this formula, formula number 3, you have a over s minus 1 plus b over s minus 2 plus c over s plus 4. So, you have left hand side s squared plus 6s plus 9 divided by s minus 1, s minus 2, s plus 4. And the right hand side, write down here, you must have, if you simplify, you have a s minus 2 multiplied by s plus 4 plus b s minus 1 multiplied by s plus 4 plus c s minus 1 s minus 2 divided by s minus 1, s minus 2, s plus 4. Now we create 3 equations, compare left hand side, right hand side. For s squared, you have 1 equals to A plus B plus C. This is equation number 1. Create. This is equation number 1. For the S squared. AS squared, BS squared, CS squared. All positive. For S, left hand side, you have 6S. This is for S squared. 1S squared. That's why 1. For S, you have 6. So 6 equals to 2A. We are creating second equation. Plus 3B minus 3C. So this one will be equation number 2. So we will create second equation for S power 1. Third one is a constant 9. Left hand side 9. This one. Just now this is 6S. I put 6 here and then the 1S squared. Now the third one is 9. So 9, you have equation number 3. 9 equals to, this is the algebra class, minus 8A minus 4B plus 2C. This one, equation number 3. You create using the formula. Using the formula number 3, you create 3 equation. So from equation 1 and 2, equation 1, you multiply by 3. 3 equals to 3A plus 3B, 3C. Equation 1 multiplied by 3. And then you add with equation number 2. So you will have 3A plus 2A, 5A, 3B plus 3B, 6B, 3C minus 3C, 0, and 6 plus 3, 9. So 9 equals to 5A, 6B. And then from equation 1 and 3, you can solve 1 and 3. So equation 1 is multiplied by 2, 2A, 2B, 2C equals to 2. And then you make use of equation 3. Either you can minus 9 minus 2, 7, minus 8A minus 2A minus 10A, minus 4B minus 2B minus 6B. Now you can solve 9 equals to 5A plus 6B and minus 10A minus 6B. You add, you get 9 plus 7, 16. 5A minus 10A minus 5A. So if you solve this equation, you get your A equals to minus 16 divided by 5. This is your A. You solve. Similarly, you solve for B. Once you have A, so 5A plus 6B equals to 9. Your A is minus 16 over 5. So you can find your B. So your B will be equals to 25 over 6. 25 over 6. So this is your B. So after that, you can use to find your C. Because A plus B plus C equals to 1. So your C will be 1 over 30. So if you calculate your C will be 1 over 30. So you already found your ABC. So after you find ABC, inverse Laplace of minus 16 over 5 S minus 1 equals to minus 16 over 5 e power t, because your A is 1, plus inverse Laplace of 25 over 6 divided by S minus 2. Your A is 2, so the answer is 25 over 6 e power 2t, plus inverse Laplace 1 over 30 S power 4 is 1 over 30. Your A is 4. So therefore, e power minus 40. So you are using the formula from the table. That is EAT, inverse Laplace of 1 over S minus A. So your A is minus 4. If you put minus 4, you get S minus 4. So your A is minus 4. Any question, class? Example 5. You got to do your homework. It's a long calculation. Use the formula number 3. So number 3 is very suitable for example 5. Any question, class? Before we move on. Yes, Wong. You got to practice. You got to right. Sir, what about the A is 4? Which A? Which A? What do you mean? Which A? Yes, Wang Chen. Wang Chen, are you there? Yes. What do you, which A? S plus 4, that is the last one. 1 over 30, e power minus 40. Go back to the table. Go back to the table, this one. This, we are using this table. Number 3, yes. All must use this table. Wang Chen, number 3. Slide 5. Slide 5 is very important. So, whatever you do, you must match with this. If you do other than this, for sure you cannot get the correct answer. So, this slide 5, equation 1, 2, 3, 4, 5, 6, 7, many more to go. But we just use only 7 to make your life easier. We just limit ourselves for the 7 famous formulas. Apart from that, there are many, but we are not going to deal with that. And this slide 5, okay, slide 5, and then for you, this is new. New in sense that you may have forgotten. This slide 14, also very important. Also very important. Because you cannot use as you like. You must select from here. But if you find the form is not here, 1 to 6, then we cannot do at this moment, because we are given only these 6 forms. Outside these 6 forms is very difficult. But we are sure this sixth form is sufficient to solve any problem within this syllabus. Because it's outside this, then we cannot do that. Then it becomes very complicated and very difficult. So we limit ourselves with this. So I think these two examples, many more examples you can see in the ULearn later on. More exercises. You got to practice this. Because there is no direct formula to handle this. You cannot do one shot. No. This one got 3 pieces. 1, 2, 3. Sometimes 4. Sometimes 5. So if 5, but still you have to select from here. Because this is only 3. But you may have more than 3. But that doesn't mean that it is not same as 3. No, it is same. So anything other than this, you must make sure it is within this. You cannot say, if I have 4 factors, that means there is number 7. No such thing like that. There is no 7 here. It must fall within these 6. You got to match it. So, for example, x minus a power 4. I put 4 here. But if I put 4 here, this one is px plus q. So this one x power 1, x power 2. So if I put 4 here, this one may be changed. So that is difference. This one, because px power 1, you must see the power also. You must match. This one x power 2, 1 power higher than this. Similarly for this, you see x cubed, this is x squared. And this table also incomplete because there are many things will not be exactly same as this one, the form. So if not exactly same as this, somehow or other you got to match. And you try to find the partial fraction decomposition. Try your level best. If you cannot get, that means the problem cannot be solved. So somehow or other we got to find. Any question, class? 3.2. So if you look at this 3.2, all is about inverse Laplace. We have simple one in the beginning. So you can see this is a very simple one. This table is very basic, but the problem cannot be as simple as this. This is just a formula guide. But the problem will be very complicated. This one is very simple. This one, especially the example 5. So example 5 and example 4, of course, change this s must be small s, yeah? This is s domain, small s. Okay, now we move on to another section, the next section. Any question, class, so far? Apart from Wong, what about others? Chia? You okay, Chia? Roger? How are you, Roger? Any question, Roger? Yeah, Roger. Yes, no problem. Thank you, Roger. Thank you very much. So, okay, still okay. Yeah, you got to try. You got to try. Try again and again. You got to try again and again by yourself. You got to practice. This, you have to do a lot of exercises and practice. Do it. Okay, you got to try. So what is next class? Translation theorem. What is this? Of course, the final goal is this one. This is very, very important for the engineers. But we cannot do this. This one next week. So translation theorem 3.3. Yeah? So okay. So 3.3 is about translation theorem. It will be getting more lengthier. What is this translation theorem? It is to do with these two. These two, Laplace transform, inverse Laplace transform. So extension of 3.1, 3.2. Combination. We combine. So use translation theorem to find Laplace as well as inverse Laplace, both. Now, what is first translation theorem? You know Laplace of ft is fs, the capital Fs. And a is any real number. Then Laplace of EAT, now you add this. This is called translation theorem. Laplace of EAT ft equals to f capital F of s minus a. This s become s minus a. This s become s minus a. So in simple form, Laplace of e power at. A is any real number. A is any real number. Laplace of EAT ft equals to Laplace of ft. But your s becomes s minus a. Take note this one. Arrow. So your s becomes s minus a because of this term. This is very important. Okay. So now, if this is Laplace, what about inverse Laplace? That we will see later. So inverse Laplace, we will see later. First, Laplace first. Okay? All right. But you must have the table with you. Otherwise, cannot. So you have the table in 3.2, the table slide number 5, 3.2. And also the Laplace table in 3.1. So, example 1, but you must use this together with Laplace of ft. This one combined with this. Because you don't have e phi t only, e power phi t, t power 3. So Laplace of e power phi t multiplied by t power 3. So Laplace of this, we must use translation theorem. So the translation theorem says Laplace of EAT ft is Laplace of ft, but s becomes s minus a. So here, this one match with this. Your a is 5. And your ft is t power 3. So this one equals to Laplace of t power 3, but your s is s minus 5 because your a is 5. So Laplace of t cube, according to the formula in 3.1, slide number 18, 3.1, slide number 18, Laplace of t power 3, 3 factorial s n plus 1. N is 3. 3 plus 1, 4. And your s becomes s minus 5 according to the translation theorem. So 3 factorial is 6. S power 4 becomes s minus 5 power 4. So this is your answer. Laplace of e power 5t, t power 3, answer is 6 over s minus 5 power 4. Now, Laplace of e power 2t cos 4t. All right, this one. Your EAT equals to e power 2t. Ft is your cos 4t. So Laplace of EAT Ft, this is translation theorem. Yeah, you must make use of this. Laplace of EAT Ft equals to Laplace of Ft. S becomes s minus a. S minus a. Your a is minus 2. Your a is minus 2. In this case, your a is minus 2 class. EAT. A is minus 2. So, cos 40 s over s squared plus, this is cos 40. So, cos kt. Use the formula cos kt s over s squared plus k squared. K squared 4. Cos 40. Cos 40. K is 4. So 4 squared is 16. But your s is s plus 2. S minus 2. According to the formula, s minus a. But s minus a is minus 2. So minus positive. Now, you replace s with s plus 2 and then divided by s plus 2 squared plus 16. So, Laplace of e power 2t cos 40, s plus 2 divided by s plus 2 squared plus 16. So, this is your Laplace of e power 2t cos 40. Any question, class here? Can I see example 1? Yeah. Yeah, what is the problem? Yeah, example 1. Yes. Yes, Mohammed Shahilin. Yeah, example 1. Yeah. Yeah. Example 1. Yeah, what is the question? Example 1, e power 5t, EAT. So your a is 5. Your ft is t power 3. Now, according to the translation, you must use this class. Very important. I go back to the slide. This one very important. Without this cannot. You must understand this. Laplace of EAT Ft equals to Laplace of Ft. S becomes x minus a. This is called translation theorem or first translation theorem. So, Laplace of t cube, going back to your Laplace formula, t power n factorial, Sn plus 1. So, n is 3. So, 3 plus 1, 4. 3 factorial. But your s is s minus a. Your a is 5 here. Write down. A is 5. A equals to 5. So, s becomes s minus 5. So, this s, you must replace s minus 5 power 4. If you don't replace, you just write like this, is not correct. This one is correct. 6 over s minus 5 power 4. So, Laplace of e power 5t t power 3 equals to 6 over s minus 5 power 4. This one not correct. This one, not yet. Huh? This one, no. This one is question mark. Is incomplete. This one is correct. 6 over s minus 5 power 4. Now, this one, EAT e power minus 2t. This fella is equivalent to this one. FT is cos 40. Don't confuse, yeah? That's why we have to highlight this always. This one is important. Laplace of EAT, the order must be the same. You have to rearrange. If they write cos 40 e power 2t, you have to rearrange. Make this same. Example 2. So EAT, so A is minus 2. So in this case, your A is equals to minus 2. And then cos 40. So your K is 4. So S minus A. S minus A. So your A is minus 2. So cos 40 S over S squared plus 4 squared. But your S plus 2 because S minus 2. So equals to S plus 2. So S become S plus 2. So you must change this whole thing become S plus 2. This one correct. This one S plus 2 here correct. 4 square you must write 16. So the correct answer, Laplace of e power 2t cos 40 is equals to S plus 2 divided by S plus 2 square plus 16. S plus 2 divided by S plus 2 square plus 16. Now, this one, inverse. Inverse. How to do inverse for the translation theorem? You see here, first Laplace of EAT FT Fs minus A. Inverse Laplace of Fs minus A, I bring this right hand side, equal to inverse Laplace Fs, S become S minus A. Therefore, the answer is EAT FT. But this must be S minus A. Then only EAT FT, A is this A. And FT is inverse Laplace of Fs. Now, using this inverse Laplace formula, we want to find this one. But this one, evaluate inverse Laplace, 2s plus 5, s minus 3 squared. This one, you must use partial fraction, the table. They already done for you already. So you got to do this as a homework. Now you see here, power 2, this is power 1. So a over s minus 3 plus b over s minus 3 squared. So your a is 2, b is 11. You ought to find. This is what we call the partial fraction. This partial fraction comes from the table 3.2, slide number 14. So this one, no time to do now. So you got to do by yourself. Because we are in the process of finding inverse Laplace. So once you have these two, then very easy. Very easy. This is the problem. That's why we gave you the table, form of the rational function, the column 1, and then column 2, form of partial fraction. So you must use that, find your A, capital B. Now you decompose 2 inverse Laplace 1 s minus 3 plus 11 inverse Laplace 1 over s minus 3 squared. So these two take out inverse Laplace 1 over s minus 3. Your A is 3. This one directly e power 3t. No need to use any translation theorem. Directly go to 3.1, slide number 18, using the formula Laplace EAT 1 over s minus A. Inverse Laplace, of course, you can go to inverse Laplace formula. That is 3.2, slide number 5. EAT is inverse Laplace of 1 over s minus A. This is E3t. This one for the inverse Laplace, this one. 2. But this one, 11 inverse Laplace 1 s minus 3, you must use translation, because this one s minus 3 squared. So s minus 3 squared, in this case, s minus 3 squared. This formula is square, so you cannot have e, because this is square. So according to the formula, the inverse Laplace fs s minus a EAT ft, this one s minus 3 square, you can write s square. So s square, but s is s minus 3. S square, if you look at formula 3.2 inverse Laplace, slide 15, Laplace of t power n. T power n is inverse Laplace n factorial Sn plus 1. So the n is 1. So t power 1. So your EAT, A is 3. This formula, you are using this formula. Ft is t power 1. Because this n is 1, n plus 1. So using this formula, EAT ft, A is 3. So E3t multiplied by t. In fact, E3t multiplied by t, but they put t in front. So the answer is 11 t e power 3t. So this is your final answer for inverse Laplace of this. Any question, class? Yeah, any question? Example 3. You must use translation theorem here, because this one is not same as this one. This is power 2. Power 2, you have 1 over s power 2. But s is s minus a. S is s minus a. So your a is 3. So E3t, and then ft is t power 1. You got to modify, class, modify this according to the formula number 2 and number 3. You saw just now the inverse transform got 7 formulas. So formula 2 and formula 3. So this s minus 3 squared, you cannot use EAT directly, because EAT is only for s minus a, not s minus a power 2, no, or power 3, no. only s minus 3. So this inverse Laplace FAS S must write s minus 3 as s squared. But s is s minus 3. It's in another way. This is confusing because you have a translation theorem, one thing, and you have an inverse transform, formula 2 and 3. You got to be careful. Formula 2 is the right formula because you have t is t power n. In this case, of course, ft is t. Because this s, as I said, the matching s power 2, right? So s power 2, n plus 1, 2. So n factorial, 1 factorial, that is 1. So it is Laplace of t. Laplace of t power 1. So n is 1. So there is no effect on the factorial. Okay, now we move on to the next one, this one. This one is little bit, you have to do some maneuver, some rearrangement only. You no need to use partial fraction because this one, this term, you cannot put like s plus a multiply s plus b. You do in another way. That is completing the square. There is a word in algebra. We call it completing the square. Because this 6s is 3s plus 3s. 6s. So you can, because we can use translation theorem. That is good thing about this kind of problem. Partial fraction is one side. You cannot apply partial fraction all the problems. No. Answer is no. So here we adopt a method called completing the square. This is the beginning. How to handle this part. That is algebra. Algebra is to do all this kind of completing the square, partial fraction, equating the left-hand side, right-hand side of the fraction. You may wonder, what is this to do with Laplace transform? Of course, it is not directly involved. Indirectly, it is a backbone. Because to make this inverse Laplace easier, you have to study algebra. No way. You must refer to algebra. So what is the algebra here? This s squared plus 6s plus 11, you have to nicely written as s plus 3 squared plus 2. Because 9 plus 2 is 11. This is the trick, class. This is the trick. T-R-I-C-K, trick. This is the trick they play here. So, since this is s plus 3 squared, you must modify this s. Become s plus 3 minus 3. Because this is s plus 3 squared. So, you decompose this, inverse Laplace s plus 3, divide by s plus 3 squared plus 2, minus 3 over s plus 3 squared plus 2. You may wonder how we got the idea here. This is the thing that you got to do with the information from the table. So the table I'm referring to is the 3.2, slide 5, equation 4 and equation 5 together with the translation theorem. Now you already finished translation theorem. Okay, but you already have the table under section 3.2, slide number 5. You got to mix everything, class, because this is already passed. So you must make use of that. The reason why they do this, because they know this one goes to cos, this one goes to sine. That is the ultimate output. But how do we know this before? That is the challenge. That's why you got to study this, practice more, and try more exercises. If you do other ways, let's say you don't want to do this way, you want to do different way, can, but the final output must be the same. Because this is already a fixed, precise problem, exact problem. Now, if you follow this one, what is next? You see this slide? So, inverse Laplace s plus 3 divided by s plus 3 square plus 2. These two you can write root 2 square. This is matching. And this one, 3 outside. Put here. And then 1 over s plus 3 squared. These two, write root 2 squared. Matching now. This one, because s plus 3, you use translation theorem. That is inverse Laplace fs s minus a eat ft. So your a is minus 3 here. Minus 3 because s minus 3. So therefore, e minus 3t. This one is cos. From where? From the table 3.2, slide number 5. Cos root 2t, not 2t, root 2t, because root 2 square. The formula says root 2. K here is root 2. Now this one, you have to put root 2 here because the sign formula is like this. Inverse Laplace root 2 s squared, because here you already put root 2. So you put root 2 as a numerator, must divide by root 2. So this one minus 3 over root 2. Again your a is 3 minus 3. S minus 3 according to the translation theorem. Here we are using translation theorem. A is minus 3. So e minus 3t sine root 2t. So this is the correct answer. E minus 3t cos root 2t minus 3 over root 2 e power minus 3t sin root 2t. Any question, class? Any question here? Any question? So, class, this one is more on manipulating. You got to be very smart. You got to be very smart. You have to do the manipulation like this. You see how this is what we call tricky class. So you are not using partial fraction. Remember, yeah? In this case, no partial fraction at all involved. The reason is this one is difficult to factorize. Remember, yeah? This one is difficult to factorize. This one not factorization. This is called completing the square. This one is not factorized. It's not like s plus a, s plus b. It's not like ax squared plus bx plus c. You put x plus a, x plus b. That is called factorization. This is all knowledge in algebra. Algebra is to do all these kind of things like factorization, completing square, elimination, substitution, cancellation. All this is, in algebra, you study all this. So you got to observe carefully how to do this maneuver, how to maneuver this, in which way we want to bring this. end of the day, class, you must get this answer. How to get this? Now you may say, I want to do my style. I don't want to follow this. I don't want to follow this. You want to do your way. Can you get this answer? Yes. If you get this answer, you get 10 over 10. So this is, as far as at the moment, this is the best way to do. This is the best way to solve. This is the best way to solve. But if you have another shortcut way to do, all this is about shortcuts. But you use an intelligent way. Shortcut means the output must be correct. The output must be correct. If you do another way, you must get this output. Okay, now we come to this. This one, s minus 1 power 3. So your n is 2. Okay? Your n is 2. You go back to the translation theorem. Translation theorem. Inverse Laplace fs minus a EAT ft. So the formula s minus 1 power 3, your n is 2. So in this case, this part, yeah, I'm handling this part. Your n is 2. N is 2. Just to give you a quick answer. So n plus 1, 3. N is 2. So the Laplace of inverse Laplace of 2 factorial divided by s power 3. So you have 2 factorial. So 2 factorial, you got to divide by 2. So 2 factorial is 2. This. But according to the translation theorem, your EAT fs minus a is 1. So this is e power t. And then this is t power 2, because this is s power 3. So the answer is half et t power 2. Now, for 1 over s squared plus 2s, you got to do the factorization and then look at the formula. This one, s squared, write down, yeah, s squared plus 2s minus 8 equals to s plus 1 squared minus 9. S plus 1 squared, because s plus 1 squared, s plus 2s plus 1. 1 minus 9, 8. So you write this term as small letter x plus 1 power 2 power 2 minus 9. This is called completing the square. So inverse Laplace of 1 over s plus 1 squared minus 9. So your a, according to translation theorem, so s minus 1. So your a is minus 1. A is minus 1. And then you see the formula, inverse Laplace of k over s squared minus k squared. So inverse Laplace of your k is 3. So 3 over s squared plus 1 squared minus 9. Outside you must divide by 1 over 3. So that's why the 3 is here. And then Xing. This is Xing because s squared minus k squared. k squared is 9. So k is 3. So your k is 3. And then your s plus 1, s minus minus 1. So a is minus 1. So EAT, E minus t. And then Xing 3t divided by 3 multiplied by 1 over 3. So that is the answer. So this is the correct answer, class. This one for this part and this one is for this part. Any question, class? Refer to Xing KT. So your A here was S plus 1, S minus minus 1, A is minus 1. And your K is 3. Any question, class? Muhammad Amir? Muhammad Amir? Wang Chen? This is the last slide, class. Example 5. So after that, no more already. Yes, Wang Chen. So, the summary of this is the translation theorem. This is the trick, class. Translation theorem, and then the formula inverse Laplace transform. Inverse Laplace transform. And then the Laplace transform. And final one is about partial fraction. So that's all for today. Any other question? Regarding your quiz 1 is on A, 4 questions. Yeah, Wang Chen. Thank you. And then quiz 4 questions, multiple choice, and you are given 50 minutes. Yeah. Any question, class, before we
you.